What's good, everybody? In my video today, we're talking about transformation of quadratic functions. I'm going to show you everything you need to know. So the first thing we need to start off is just the equations and the parent graph. So when we see y is equal to x squared or f of x is equal to x squared, we're going to have a U-shaped parabola graph like the one you see here. Now, let's just imagine if any of these equations, right, we made the x squared negative, or there's a negative sign out in front. What that does is just make the graph open down. So instead of a U-shaped graph like this, our graph is going to be an upside down U. So this is just the basics of understanding the equation and whether the graph opens up or down. Now, in the second part of our video now, we're going to focus on the shifts. So we're going to have a horizontal shift when we have the equation f of x is equal to x minus h, or if we have f of x is equal to x plus h. So what this does is this is either going to shift that graph to the left or to the right. So when it's minus h, guys, just remember that we're shifting our graph to the right. And then when it's plus h, we're going to shift our graph to the left. So that's our horizontal shifts. Now, when we go to our vertical shifts, meaning up or down, what's going to happen is we're going to have a outside factor. It's going to be k, right? So now what we're going to have is f of x is equal to x plus k, or we're going to have f of x is equal to x minus k. And the difference between the horizontal and vertical shifts is that if k is positive, guys, that means we're going up. And if it's negative, that means we're going to shift that graph down. So please just make sure that you understand that basic information. Now we're going to jump into some practice problems with transformations. In the second part of our video, guys, going over some examples, understand that these transformations are based off the original graph from the beginning of our video. So when we look at this first problem in black, it says g of x is equal to x squared minus 5. So when there are no parentheses, typically we're going to have a vertical shift either up or down. So from the origin, this transformation is just telling me to go down 1, 2, 3, 4, 5. So when we're down here now, I know that my vertex is going to be 0, -5, and then we can make a sketch of this parabola. So it should look something like this. Now, in the second example, things are just a little bit different. We do have parentheses, and when we have parentheses, we're normally going to have a horizontal shift either to the left or to the right. Just remember the shift is going to be the opposite. So it's not going to be at -5. We're going to shift actually 5 spaces to the right. So from the origin, I'm going to go over 1, 2, 3, 4, 5. My vertex would be 5, 0, and then we will be able to make a sketch of this parabola. Okay, so those are the first two examples that we have. Let's go on to the next two. So when we move over to the blue equation, guys, right, always remember that HK is our vertex. So when I look at this now, the blue equation, or quadratic equation, I should say, is telling me that I'm going to shift this graph to the left 1, and then we're going to go up 3. All right. So that means my vertex would be equal to -1, comma 3. And we're just going to make a little sketch because my equations are in the way. So sorry about that, guys. Now, when we switch to the last example for this section of the video, right, it tells us that f of x is equal to the opposite of x minus 1 plus 4. Now, what we have to understand is that once we shift this to the right 1 and we go up 1, 2, 3, 4, we need to know that our vertex is going to be +1, +4. But instead of our graph opening up like the other 3 examples, this graph is going to be opening down because of this negative sign in front. So now my graph is going to look something like this when I make a sketch. So just please make sure you guys understand how to do transformations, whether they're vertical, horizontal, or they even ask us to do both. Now what we're going to do is focus on vertical compressions and vertical stretches, which is normally, right, when we have a number in front, which is represented by A. Stick around for the next part of this video. In this part of our video, guys, we're talking about vertical compressions and vertical stretches. And we're going to be focusing on that A factor from the equation. So when A is greater than 1, that means the graph is going to be vertically stretched, meaning it becomes narrower. But if for some reason, like in our example here, A is greater than 0 but less than 1, is going to become wider. That's going to make the parabola be wider. So let's pick 3 points and see if we could figure out how true this is. So the first thing we're going to do is plug in 0 for x. Once we do that, our y value is also going to be 0. So this first point would be at 0, 0, right? There was no transformation. It didn't say any of that. We just know it's going to be compressed. Now, if we go and try to plot a second point, let's pick 2, right? We're going to do f. When x is equal to 2, what is our y going to be? And what we're going to get is half of 4, which is going to be 2. So when x is 2, that means y is also 2. And when we remember how the axis of symmetry works with quadratics, there is another point that is going to be identical to this on the opposite side of the axis of symmetry, which will be negative 2 comma 2. So when we look at this right here, guys, let's just estimate, right? We could say this is 2 comma 2, and there's a adjacent one, negative 2 comma 2. And now we're going to get one more point. So in our last point now, we're going to pick 4. So when we plug in 4 for x, this is what we're going to get. After we square it, we're going to get half of 16, which is 8. So I know when x is equal to 4, my y value is equal to 8. And remember, on the opposite side of the axis of symmetry, there's another point that is identical, meaning negative 4 comma 8. So what we understand is this graph now, right, if we just estimate this, is going to be wider than those parent graphs that we had before, right? So this is how this parabola should look. Once we draw it out, it should be a little bit wider than normal. And just understand, guys, that this is a sketch. But before we go, let's go over one more problem where we're going to look at a vertical stretch because A is greater than 1. In our last problem of the day, guys, we're now going to look at when A is greater than 1. But before we go on, if you found this video helpful, we're going to ask that you smash the like button for us. It really helps us to get our video out to more students. So now A is greater than 1, meaning our graph is going to be stretched, it's going to be narrower. So we know the first point 0, 0 is going to stay the same because there's no vertical or horizontal shift. But what we're going to do is plug in 2 for x and see what we get. When we plug in 2 for x, we're now going to get 2 times 4. We're going to get 8 as an answer. So if you remember compared to the last problem, we now notice that the y values are climbing a lot faster. So this graph is going to be narrower. So let's say that right here is 2, 8, and we know we have another point that is identical to it on the other side of the axis of symmetry, which is negative 2, 8. Let's just label these real quick, right? So we see the graph is getting stretched. It's getting closer. Now, if we go back and we plug in 4 for x, how will this make the graph look? Well, let's take a look. So we plug in 4, and what I notice is I'm going to get 2 times 16, which would give me 32. So we're saying that when x is 4 or when x is negative 4, our y value is going to be 32. So compared to the last problem, that y value is shooting up so much, right? It's going to make this graph a lot more narrower. So this is what we mean when we talk about, let's erase this real quick. I'm sorry, guys. Get that out of the way. This is what we mean when we say that the graph is going to be vertically stretched. And once we compare this, right, even though it's a sketch, when we compare it, do you guys see how much more narrower the graph is? Exactly. Hopefully this video was helpful for you guys. If it was, smash the like button for us. Leave any comments down below for future videos you guys would like to see. Thank you so much for joining me today on our transformations video. This is Algebra 1 with Mr. Peters.